Hello friends, now we are finding what is the relation between electric field intensity and electrostatic potential at a point in an electric field. We already seen the definition of intensity of electric field as it is the force experienced for a unit positive charge at that point, whereas electrostatic potential at a point is the work required to bring a unit positive charge from infinity to the given point. Now see what is the relation between these two quantities. For that, here we have a point charge. Suppose we are placing a point charge plus Q at the point O. Here in this electric field of this charge, we have 2 points B and A, which are separated by a very small distance dr. The distance between A and B is dr. And we placing a small test charge plus Q at point A. We are placing a small test charge at point A. Okay, so if you are comparing the potential at B and A, the potential at B is somewhat greater than potential at A. If potential at A is V, then potential at B should be somewhat greater, that is V plus dV. So what is the potential difference between A and B is, that is dV. A very small potential difference is there between A and B, that is dV. But we can consider the electric field at point A and B are somewhat same, because we know that electric field is inversely proportional to the square of distance, whereas potential is inversely proportional to the distance. The decrease in electric field is negligible comparing to the decrease in potential, because potential is inversely proportional to square. The change in electric field is inversely proportional to square. The change in electric field is somewhat very small, whereas change in potential is somewhat considerable. So the electric field at A and B we are taking almost same, whereas potential difference is there between A and B. What's potential difference between A and B is dV. Suppose now we are moving a small charge, that is test charge plus Q0 from A to B. So actually this Q0 experience an electrostatic repulsive force now because of this repulsive force of our source charge. What is that force? That force can write as F is equal to repulsive force F is equal to Q0 into electric field. I'm putting a minus sign because we have to apply the force opposite direction of this electric field. If this is applied force, electric field is opposite direction of the applied force, because then only we can move the charge from A to B. This force should be equal to Q0 into E, otherwise the charge will be accelerated. Okay, now the external agent is applying this force. So now we are calculating what is the work done by this source. The source doing a small work, that's dW is equal to the F dot dr. F dot dr. The work done is equal to F dot dr. Or dr is the small displacement. Dr is a small displacement between A and B. F is the applied force. So what is work done? That work done is equal to dW is equal to, substitute for F, that is minus Q0 E, minus Q0 into E dot dr dot dr. dW is equal to minus Q0 E dot dr. So we calculate the work done in terms of electric field. Now we can calculate the same work in terms of potential also. How? Because the work done is equal to work required to move the charge from A to B is equal to dW is equal to charge into, we can write as it is equal to charge into potential difference between A and B. PD means potential difference between A and B. Okay, so we are taking a charge Q0 from A to B. Potential difference between A and B is what? dV. So we can write as the work is equal to, small work is equal to, dW is equal to Q0 into potential difference between A and B, can write as dV. So now this is equation 1, work in terms of electric field. This is equation 2, that's work in terms of potential. Now compare these two equations. When you are comparing these two equations, the right side of this equation 1 is minus Q0 into E dot dr is equal to, right side of equation 2 is Q0 into dV. So Q0 is common on both sides. Now E is equal to, take this dr onto the right side with a minus sign is here. So dV by dr with a minus sign. So this is the relation between electric field and electrostatic potential. Intensity of electric field at a point is equal to minus of this term dV by dr. Actually measure how potential is changed with respect to the distance. So we can call that quantity as dV by dr as potential gradient. The negative of potential gradient. Intensity of electric field at a point in an electric field is equal to the negative of potential gradient. Actually this minus sign in this equation shows that the potential decreases in the direction of electric field. Potential decreases in the direction of electric field, or electric field is in the direction of decreasing potential. That is, this is our positive charge, source charge. Electric field due to this charge is in this direction, towards right side. We know that potential is decreases when you are moving in the direction of electric field. If you are comparing the points, this is the direction of electric field. Potential at B is greater than potential at A. That is, potential decreases in the direction of electric field. Now let us see how can you find the electric field. This is the how can you find potential if electric field at a point is given. How can you find the potential if electric field due to a point is known? So use the same equations, that is, we have E is equal to minus dV by dr. So we have dV is equal to what? We can write as dV is equal to minus E dot dr. Minus E dot dr. dV is equal to minus E dot dr. So in this electric field, suppose in the electric field of this positive charge, we have 2 points, okay, which are at a distance r1 and r2. Consider 2 points in an electric field like this. Suppose this is our source charge. 2 points in the electric field, okay, A and B are the 2 points in the electric field of this charge which are at a distance r1, okay, which are at a distance r1 and r2. A is at a distance r2 and B is at a distance r1 from the source charge. So if you want to find what is the potential difference between A and B, we can integral dV on both sides. Integral dV within a limit v1 to v2. Integral dv within a limit v1 to v2 is equal to integral with a minus sign we keep outside, from r1 to r2 e dot dr. That is r1, okay, at a point r1 potential is v1, at a point r2 potential is v2. Now suppose r1 is at infinity. If r1 is equal to at infinity, potential at that point will be equal to 0. We know that potential at infinity is equal to 0. Now how this equation will change, as we are changing v1 is equal to 0, 0 to, okay, v2. Now no need to take v2, we can take as v, 0 to v integral dv is equal to integral r1 to r2, integral r1 to r2 e dot dr with a minus sign. Now integral dv we can take as integral dv as potential. Potential at a point is equal to, v is equal to minus of integral. Okay, now we taken the r1 is equal to infinite, and instead of r2 we can take simply r. Infinite to r e dot dr. This is potential at a point is equal to minus infinite to r e dot dr. This is the potential at a point if electric field is given. How to calculate potential at a point if electric field at that point is given? V is equal to minus of infinite to r e dot dr. And the relation between electric field and electrostatic potential at any point you can write as E is equal to minus dV by dr. Electric field is the negative of potential gradient. Thank you.